Now we come on to the electronics, and this is something which we're in danger of the show becoming a nerd's paradise.
Indeed, indeed.
But this is something that Andrew and I are both very well qualified to look at, as you'll see in a moment. This comes from a blog which you can look up online called the Astro Engineers blog from 2010. This was posted. I was only made aware of it maybe 8-9 months ago, something like that. It's a 14,000 word expose of someone's experiences while working for the Jet Propulsion Labs on the Curiosity system. In particular, these two guys were software engineers, or appeared to be software engineers, certainly had good knowledge of the software of the Curiosity rover. As I say, 14,000 expose of their explanation of what happened when one of them started to investigate a problem on the Curiosity rover. Now, do you want to explain it?
Yeah, I mean, it was very interesting. I wasn't aware of this until we discussed this interview about a week ago or so, or something, and probably less than that. So I read through this thing, and I looked at it initially, and I thought, oh no, it's too long to read now. But but as I began to read it, as you said, being a bit of a nerd myself, I was kind of drawn into it, and the discussion struck me as very authentic, and I couldn't really. It mentions things like aspects of Unix and Linux, which are operating systems, which seemed to me totally legitimate. And the way that they described the fault finding that they were essentially doing was also, it just seemed exactly the way I would have done it. And the guy that was doing this initial fault finding was clearly very competent and very knowledgeable and highly skilled in what he was doing. And the way his friend describes their working relationship will also, I mean, I've experienced working relationships like just as he described in the work that I've previously done. And it's almost like when you read this blog, it's almost like you're working with them because it's very well written. And I couldn't find any, I did sort of stop halfway through and I'm thinking, well, is somebody just spinning a good yarn here? But it really, to me, by the time I got to the end, I did think it's probably a genuine account.
Right.
That what they'd written to me did seem to be genuine.
Right.
And the scenario is that they were basically looking into a scenario where one of the rovers had failed to respond to a command which had been given to it. And this is flagged up automatically as something that needs to be investigated by, the techie guys. So they did what's called a memory dump, where they actually saved out a portion of the rover's memory, the RAM, to look at what software was actually running at the time this fault occurred. And they talk about reverse engineering the assembler language back into C code.
Decompiling.
Exactly, yes. So that they could then work out what had caused this fault or what software was running when this fault happened.
He was able to then work out the C code.
Yeah,
right.
That's right.
So he could then actually
go back to the source code that they had and work out which module and which application, which subroutines were actually running.
Yeah.
And during the course of that analysis, they found some code which had been loaded into the RAM, which they didn't recognize. And looking at the memory mapping within this code, it appeared to be talking to another module. And these modules have a particular I/O address, input-output address in the system. And so when they looked into that, and they had all the specs for the rovers and how they worked and how the systems worked, and you've put some more of that in the hypothesis, haven't you, about the VX works and the VME bus, which is what you worked with in your work. And so they then, after a period of, I think, a couple of weeks at looking at this in their spare time, sort of under the table, so to speak, they worked out that what appeared to be happening was this code was talking to another radio module. And further to that, they were able to retrieve some of the data which this radio module had been working with. And it turned out that they were able to actually save out some of this data and it turned out to be thumbnail images, which are these little versions of images that you see on a digital camera. You know, when you have taken a load of pictures and you want to look at the preview, you see these tiny little images. They're called thumbnails, and this is what they were able to retrieve. And then after several weeks, maybe a couple of months, they actually went to the length of taking the thumbnails that they'd managed to retrieve from the analysis that they'd done and comparing those with other thumbnails which are already on their image database.
Well, they did a scan of the whole JPL network. One of them had access to other departments within JPL because he was an administrator of some kind. And they generated their own thumbnail, and then which had specific characteristics within it, because it was generated using this specific function. And then they did a scan comparing it, and they found some thumbnails would have been generated with the same code.
That's right.
So someone in the JPL company had access to this secret code that was running in the Curiosity rover. So,
I think it was the Opportunity or the Spirit, wasn't it?
Yes.
It wasn't
Curiosity.
It wasn't
Curiosity.
It was either the Spirit or the Opportunity.
Correct.
So they done that, and then they actually found where these, shall we say, secret or rogue thumbnail images, whatever you want to call them, these clandestinely retrieved thumbnail images, they found where they were stored. And they were stored, what was the name of that group that they were stored?
I've got it in here.
And they were basically stored in another office, which was a couple of buildings away from where they worked, or maybe even another site, but it was the quantum...
Yeah, there was a department in JPL, which in this group does exist.
Just search for quantum if you haven't got it.
Yeah.
Control F, quantum.
Control
F for find. Yeah. And then just search for quantum, because I forget, that was the first word, wasn't it?
Yeah.
And if it was like quantum...
Yeah, so there's a department in JPL called Quantum Sciences and Technology, and they had these images on one of their systems.
Yes.
So they then started to eavesdrop on part of their network and found that they were in communication with the one of the rovers in real time.
Correct.
In other words, normally it would take between 6 and 20 minutes to get a message to and then back from the rover because it's on Mars. But they were communicating with it
in real time. And they worked that out from the timestamp of the images and the way they could tell that these images had a timestamp coming from the rover, and they can compare that with when the actual file had been saved on their system.
And this is the key, folks. The conclusion that these guys come to, they said, well, this department, Quantum Sciences and Technology, have obviously developed faster than light radio communications.
Yeah.
So that's how they're able to get this back door into the rover. And what functionally what was being done to the rover is someone was previewing images, deleting some of them, and modifying some of them. Yes? They were using a specific function to change the image or to delete image. So just to expand on that, there's an extra device on the rover that no one knows about that the computer system is communicating with surreptitiously, and someone is accessing thumbnails via that link. They're reviewing them in some way, and they're deleting certain images. So there's a third party got a back door into the rover, right? And these two engineers, because they're, in my opinion, because they're so convinced that the thing's on Mars, they say, well, the only thing we can think of is that this secret department have got faster than light radio comms.
Yeah. And it kind of, when from coming out from our perspective, it kind of makes you chuckle, as we're chuckling now when you read it, because the guys don't really give a reason as to why they would employ this faster than light communications.
An explanation which is just as plausible, more plausible in my opinion, is that the thing's on the Earth and it's been communicated via some low-flying satellite.
But I mean, even if we take their explanation as being the correct one, unusual though it is, it clearly, provides some sort of scenario where, or it suggests a scenario where the images are being previewed, they are being pre-examined before being dealt with in some other way. So that in of itself is significant.
And just to go into a little bit of the electronics, as Andrew mentioned, this rover uses what's called a VME backplane. Now, I've worked with them for over 10 years in my work at Rolls-Royce and other companies, and this is it's industry standard, right? It's not something which is it's industry standard, right? It's industry standard electronics. The main processor module in the rover, it is ruggedized, so it's more robust than something you'd get in a power station or something like that. But they're using the same backplane, which I've found quite interesting. Now, normally in VME systems, you would have spare slots. So it's a bit like your computer, which has PCI slots. You normally have 1 or 2 spare in case you want to monitor something, or you could do development with that spare slot. You could use it for anything.
That's right.
And is it the case that the rover in question, I think it was the Spirit rover, does have a single, perhaps redundant slot, spare slot, and all they've done, when they've taken the rover out, the rocket, it's gone to the rover test site, and all they've done is pushed another card into the rack and then added a radio transceiver that the card is talking to. And that would be a piece of cake. But one thing you would have to do to get that to work, you'd have to, as Andrew said, you'd have to modify the software in the main processor in order to communicate via the VME bus, which is what these engineers realised.
Yeah.
So someone's added a bit of code and a bit of hardware so that the thing can be controlled and the images can be deleted via a radio link. Now, that radio link could easily be sent to a local satellite dish, and they could be sitting in the next office at JPL. So you've got one department who are getting the images and they think they're coming from Mars, and there's another department over the road who know it's on the Earth who are accessing the images in real time and deleting the ones they don't want them to see.
Yeah, and you could also argue that some of the artifacts that we've seen, perhaps those are being inserted. They're inserting some of those into the image set to make people like us raise some of these questions. Who knows?
Yeah, it's. But if you've got nerd leanings, then you'll
enjoy reading this. Yeah, if you're a bit of a techie software person, you can form your own judgment of this. But I couldn't find any flaws in it, and it's quite a sad story as well, because at the end of this, the guy who's written the story, he describes this scenario where the computer that he was using gets it gets broken into, doesn't it? The lid gets taken off. Yeah. So he gets spooked by this. Yeah. And although he's not found out and he's not taken aside by anyone at NASA, he decides to jump ship. And the friend that he was working with, he basically never speaks to him again, because he doesn't want to think that they will, if they're together.
Yeah. Because what happens is, it's when they start spying on this other department to see if they are communicating via this protocol. Someone's obviously picked up on that, and when he's gone home at night, there's a tech come in, removed his hard drive, copied all the data off it, put it back in, but they'd put one of the power cables in wrong
way around,
because he'd been in it the previous day, and he knew someone had been in and took his hard drive and then returned the hard drive. So someone was eavesdropping on him. Eavesdropping on this other team, but nothing was done to reprimand him or anything.
No, well, he basically left NASA, the guy telling the story. He left NASA because he felt that they might catch up with him, so he just left. And I think he'd worked there for quite a number of years, and he was quite sad about that.
Another frustrating thing is it's an anonymous blog. Yes. But there's a legitimate reason for that. You're not going to put your name to that for obvious reasons. They will have signed the Official Secrets Act.
Yeah, yes, indeed. And I did wonder, as I said earlier on, whether it was just a good yarn. But having read the whole thing and considered the circumstances,
it could be disinformation, but
it could be.
It's not. It's something which is. It's not on some major website. No one's picked up on it that I'm aware of.
Yeah. And remember, this is dated 2010, so this is before Richard and I started considering these scenarios where the rovers are not on Mars, way before. It was 3 years or so, 4 years before that. So
2010.
It's not like we've been fed this as disinformation, because,
Yeah. Now we'll just briefly mention the landing, particularly of curiosity, because when these rovers are sent to Mars, they have quite a payload.
Several tons, isn't it?
You know, the whole thing put together, especially in Curiosity rover, it's got a heat shield and it's got the parachute mechanism, and it's got this thing which lowers it down and then on strings, and then it gets these thrusters then fire it off. So it weighs a lot.
I think it's about a ton for the actual Curiosity rover itself.
Yeah.
I think nearly a ton, isn't it?
So the speed that it comes into the Martian atmosphere is phenomenal, and that the energy for that has to be dissipated, or it has to be accounted for somewhere. So there's a chap done quite a lot of calculations on this, which again, it's nerdy perhaps. If you're a nerd mechanical engineer, then you can download this.
You'll like it.
Yeah, you'll like it. But he reckons there's just no way the thing could dissipate the amount of energy that it has to.
That's right, because we don't go too much. It's better if you read the document to get the technical detail. But in essence, what happens is everyone's seen a shooting star at one time or another, which is a piece of dust burning up in the atmosphere. The Curiosity rover in the packaging is like a giant shooting star, and it's travelling at high speed when it gets to the atmosphere. So the basic problem is, how do you stop it burning up before it lands? And as people will probably realise, you have to have a heat shield. So the document that Richard's put together includes these calculations about how the heat shield can do its job and basically dissipate the energy from the high speed of travel, successfully. And there are certain basic calculations that you can make about the material, and he basically comes to the conclusion in this document that from the amount of heat that this would have to dissipate, it was like factors of probably hundreds or tens of thousands even, times the amount it would need to be he calls it infinitium or something, this material or something.
Well, and the other aspect, Andrew, is the parachute, where he's currently doing calculations on the parachute for both Spirit and Opportunity and Curiosity. He suspects there's problems with that as well.
Yes.
Now we've mentioned the Curiosity rover team in the press conference. If you want to watch it, just go online and have a look for the Curiosity rover press conference and see if you think these engineers really are capable of getting an object to Mars, landing it on the surface, and then communicate back with Earth. And here's them in the control room, Andrew. I don't know what they're all doing here, because, as I said, it takes between 6 and 20 minutes for the signals to get to and then back from Mars. So they can't possibly be controlling the mission in any way. It's all got to be automatic. So what are they doing in this room? But let's just take a look at this. This is the moment where the first thumbnail comes back, Andrew.
EDL ops, the signal to Odyssey remains strong.
Flight EDL images are starting to come down. We're beginning to get images.
We got
from
images
Odyssey.
coming down, folks.
Stand by for images.
Rear has 10 thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
Odyssey is nice and high in the sky. At this time, we're standing by for images. Thumbnails are complete.
Got thumbnails.
Full image complete. Full image complete.
It's the wheel. It's the wheel.
There we go. We can see a wheel image. We are wheels down on Mars.
Oh my Good. We'll do a proper hug on the other side.
Okay, so that was NASA receiving the first thumbnail from Curiosity. And it's obviously from Mars, isn't it? You can tell, 64
Clearly.
pixels by 64 pixels.
As
so
many as that?
yeah,
Well, it
as
must
many as
clearly
that.
be, yeah.
It's obviously on Mars, isn't it?
It must be, yeah, 64 by 6. That's much higher resolution than I would expect it from
Yeah.
NASA.
All right. Now, I've been in communication with NASA. I wrote them a Freedom of Information request because what I'm interested in as a former engineer, I'm fairly well up on how products get tested. And something like a Mars rover would have batteries and batteries of tests, and there would be environmental testing and what I call soak testing, where the product is put in a working environment at its working temperature, the environment at the working temperature and pressures, etc., and its functions are operated over a long period, a period which is comparable to its life. So I would expect a rover to have at least a month worth of environmental testing, where it's at those low temperatures for a month. And every day they're waking it up and they're moving it about and they're doing tests and they're seeing if it will function throughout that whole month. So I want to see the document from NASA which lists all of those tests. You know, it's probably going to be this thick. It's going to have engineers' signatures on it, and that's what I've asked NASA for. And they've asked me to be more specific about what I want. So I'm in email contact with someone from the JPL library, and I'm going to see if I can get that document because. What proves that the thing can work is not the design of it. It's the testing. That's the proof that it's fit for purpose. And also in the document, you can read the emails that I sent to Robert Manning, who was one of the chief engineers on the Curiosity rover program, who basically ran away from mine and Andrew's questions. He answered one question and then we didn't hear from him again.
I think he answered our questions because it was a case of mistaken identity, wasn't it? I think you'd explained that before.
Maybe.
Yeah, because he thought that it was another NASA person writing to him when actually it was...
Well, that was initially... there's two Robert Mannings in NASA. Yeah. I wrote to the wrong one, so this Robert Manning forwarded my email to the one I meant to send it to, and I think he felt obliged to reply the first time. Because it had come from someone else in NASA.
Yeah.
Okay. All right. Is there anything else you want to add, Andrew, with regards to this?
Well, yeah. I mean, the whole thing you were saying right there about the functional testing. I mean, something like the rover. You know, you've probably got a year of test work to be done at least. You know, like separate system tests, and then you have an integration test where you put all the modules together and check that it all works properly together. You know, as you say, you use environmental ovens and environmental enclosures to make sure it's going to work in those temperatures. You know, that's something I saw where I worked at Plessy. They had an environmental oven that they put all the components in.
I think they have shown the environmental test chamber, but I want to see details of all the documentation.
The documents, wouldn't it, with the signatures and dates and so forth. Yeah, definitely.
Yeah, because those documents are usually extremely specific, because when you write a test procedure, right, you have to assume that the person who's carrying out the tests has no knowledge of the project, right? So you can hand that to any engineer and it will give all of the parts lists with the numbers and that you can go and get them out of the stores or whatever to build the rig and put it, this is the type of chamber you need, everything listed. The capability of the oscilloscopes that you need, that's all the parts you need. Right, instruction 1, put this board on there. So it's like noddy.
Yeah.
It's like, so the actual procedure for carrying out a test is normally extremely well defined.
Yes.
Because you have to be able to repeat, they might have to repeat it in 5 years' time when people have left.
That's right.
So
that's right.
It's, the documentation, why can't that be made public? Because I'm not aware that it is public. There's nothing secret in a test.
No, I mean, it's a publicly funded project and it doesn't, I don't think there's that much technology that's patented, etc.
Incidentally, perhaps viewers can help me with, just before we finish, Andrew, just one thing I want to point out, and that is the VME rack, which I suspect is probably ruggedized to a degree. It's probably not an industry standard type VME rack. It'll have some sort of more protection on it. but the architecture electronically will be the same. And I'm saying, is there a free slot where an extra card could have been put in? I've not been able to find any photographs of the VME rack on Spirit and Opportunity rovers. Right? I've found photographs of every other component, you know, the cameras, the arms, the solar panels, the power system. I've not found any images of the VME rack, which is the box of electronics which controls the rover. I've done Google searches, no photographs of it.
It could use a sort of more highly integrated version of the VME bus, you know, that wasn't with the same pin out to save space or something like that.
Well, as far as I'm aware, it's not. It's just a standard,
standard
VME bus, and the card, which is a RAD 6000, which is a fairly standard processor, but it's bespoke.
Ruggedized, isn't it?
Yeah, it's all the components on it can withstand certain blasts of radiation, right? Now, there's plenty of photographs of the card which goes into the rack.
Ah, right.
Right, the main processor card, because that's used on other satellites.
That's right.
It's not just used in the rover.
probes, yeah.
In fact, it's been used on quite a lot of space technology, that RAD 6000. But no photographs of Spirit Opportunity electronics rack. I want to see a photograph of that rack, and I want to see, is there room for another card? Yeah. All right. Remember, believe none of what you hear and only half of what you see. I'm Richard D. Hall. Good night.